Hey guys, today we are going to talk about simplifying expressions with radicals in them. So we're going to do a sample of what's on this worksheet here. So for number 1, to write this in simplest radical forms, we're going to simplify the radical, and there's a couple different ways you can do this. One way is with a factor tree, and the other way doesn't use a factor tree, and I'll show you both ways. So this first way I'm going to do is to keep it under a radical. And I'm going to try to think of a square number that goes into 32. The biggest square number I can think of would be best. Okay, so a square number is a number whose square root is a whole number. 16 goes into 32, and 16 is a square number. 16 times 2 is 32. The square root of 16 is 4, so I can bring a 4 outside. And 2 is not a square number, and I can't find any square numbers that go into 2, so 4 times the square root of 2 is my final answer. The other way that it can be done is with a factor tree, so let's do that here on number 3. So 63 is 9 times 7. 9 is 3 times 3, and I'm down to prime numbers only. Okay, so this comes in a pair. Any number that comes in a pair, I'm going to be able to take outside of the radical. Now, I already have a 3 outside the radical, and now I have another 3 outside the radical because of this pair. So this 3 comes out, a 3 comes from this pair. Okay, now we're only looking at the ends of the branches of this factor tree, and there's a 7 left over at the end of this branch. That 7 stays inside the radical. So I have 3 times 3 outside, which is 9, and then I have a 7 inside, so it's 9 times the square root of 7. So next we're going to multiply with some radicals. So when I multiply numbers like this with radicals and numbers that are outside the radical, what I can do is I can multiply numbers that are outside the radical by each other. So I have 2 times 4, which is 8. And I can multiply numbers inside the radical by each other, so I get square root of 15. Okay, now before I walk away from this problem, I do need to be sure that this 15 is in simplest form. 15 is 5 times 3, and those are both prime numbers, so I'm not going to be able to get any pairs, so this is my simplest form. Okay, let's move over to number 8. Okay, so I've got parentheses here, so I want to distribute. So when I distribute, I have a 2 times 5 that I can multiply, so that's 10. And then the square root of 3 times 2, which is 6. Okay, then I distribute here, and I have negative 2 times 4 is 8. And then I have the square root of 3 times the square root of 3, which is the square root of 9. Okay, now I need to make sure that this is in simplest form. 6 is 2 times 3. There will be no pairs there. If I made a factor tree, I have 2 and 3. There's no pairs. So this cannot be simplified. 9, however, is 3 times 3. So the square root of 9 is 3. So what I have here is 10 times the square root of 6 minus 8 times 3. Okay, and then 8 times 3 is 24. So it's 10 times the square root of 6 minus 24. And I cannot add or subtract when I have a radical unless they are exactly the same radical, but I don't even have a radical here, so I cannot combine these. Okay, number 9, square root of 3 squared. Okay, so that's really the same as the square root of 3 times the square root of 3, which is the square root of 9, and the square root of 9 is 3. Okay, but a little shortcut here is when I have a square root of a radical of or square of a square root, those just cancel out, and I have 3. Let's go on to number 11. Okay, so what I can do is square every factor inside of here. Now, this is only one single term because there's not a plus or a minus here. If there was a plus or a minus, that would change things. But since there's not, I can just square both parts. 12 squared is 144 times the square root of 6 squared is 6. So I have 144 times 6. Okay, so we'll bring in a calculator for that. 144 times 6 is 864. Okay, we'll go down to our next section here. So now we have a radical in a denominator. So we're going to simplify by rationalizing the denominator. Okay, it's called rationalizing because this number down here is considered an irrational number, which means it can't be, this square root of 5 cannot be written as a fraction. It will be a decimal that is non-repeating and non-terminating. So it's an irrational denominator, and we cannot leave irrational numbers in a denominator. So we have to fix that. So here's how we can fix it. We can multiply by the square root of 5 over the square root of 5. Now why can I do that? Because this is really multiplying by 1. Something over itself is 1. And since I'm multiplying by 1, I'm not going to change the value. I'm just going to change the look. Okay, so across the top I have 3 times the square root of 5. And the square root of 5 times the square root of 5 is the square root of 25, which is 5. So I have 3 times the square root of 5 over 5. Okay, now I cannot simplify these because I can't divide something not in a radical by something that is in a radical. So this is my final answer. Okay, let's go to 15. So I have a square root of 7 for the denominator, so I'll multiply top and bottom both by the square root of 7. Okay, so I get 2 times the square root of 3 times 7 is 21. And the square root of 7 times the square root of 7 is the square root of 49, which is 7. Anytime you multiply a square root by itself, you get what's under the radical. Square root of 7 times the square root of 7 is 7. Now, can I simplify this radical? 21 is 7 times 3. Those are both prime. There's no pairs, so I cannot simplify any further. Okay, number 18. I actually recognize the square root of 169 as a square number, so this is actually going to equal 13 here. So I have 13 over 2 times, and the square root of 169 is 13. Okay, now in this case, since this is multiplication, so this is a single term, I can just cancel those out. So I've got 1 over 2, or I could do 13 over 2 times 13 is 26, and 13 goes into both of these 1 time and 2 times. Okay, now if I have a square root over itself, square root of 5 over square root of 5, I can just cancel those. Now if there was a plus between the number here and this radical or here, I would not be able to do this. But because it's multiplying, I can cancel that out. Okay, the fact that it's multiplying means this up here is one term and this is one term. If there's more than one term, I can't just cross something out like that. But since it's one term, I can cross those out and get 3 over 2 as my final answer.